Imagine you are chatting with a friend on WhatsApp. Your friend sends a message and it appears on your screen almost instantly. No refresh buttons, no page reload, no manual action. The message just appears. Now, here is the interesting question. How does your phone know a new message arrived? Did your phone ask the server? Did the server tell your phone? Is there some permanent connection or is something else happening behind the scene? This seemingly simple problem has led engineer to develop several different communication techniques. Over the years, four major approaches emerged: polling, long polling, server-sent events, WebSockets. Today, we will understand all four. We will see why each one exists, what problem it solves, its limitation, and how companies like WhatsApp, Slack, YouTube, Uber, Facebook uses them. By the end of this lesson, you will know exactly when to use each approach in the system design interview. Now let's try to understand how do we push updates to users and what are the problems we were facing. Let's imagine we are building a chat application. A user sends a message. The server receives it. Now the recipient needs to see that message. The question is, how does the recipient phone knows a new message exists? The server has new information, but the user hasn't asked for it yet. This is a core problem, getting updates from server to the client. So solution 1 is polling. The earliest and simplest solution was polling. Polling means the client repeatedly keep on asking to server, any new messages, any new messages, any new messages, again and again and again. Let's walk through this diagram. At the top, we have a client. Imagine this is your browser or mobile app. The client sends a request to a server. The server responds. Now notice something important. The server does not keep the connection open. The request finishes. A few seconds later, the client sends another request again and again and again. The client keeps asking, do you have any updates for me? Do you have any updates for me? Do you have any updates for me? This repeated checking is called polling. Imagine checking your mailbox every minute. Most of the time, there is no new mail. Yet, you still walk to the mailbox, open it, check it, close it, and repeat. Polling works exactly like that. Most requests return no new data, which waste a network resources. Now problems with pollings are, suppose we poll every 5 seconds. If message arrives immediately after a poll at 10, message arrives at 10:01, next poll at 10:05. The user wait for 4 seconds unnecessarily. If we reduce polling frequency every second, we improve responsiveness, but now we are generating huge amount of unnecessary traffic. This trade-off lead engineer to search for better solution, and the better solution is solution 2, that is long polling. Engineer asks, why keep asking repeatedly? Why not ask once and let a server wait until data is available? This idea became long polling. Let's follow this request. The client sent a request to server, but unlike normal polling, the server doesn't respond immediately. Instead, it keeps the request open. Then it waits and waits and waits. Eventually, new message arrives. Now the server immediately sends the response. The client receives the update and then immediately opens another long polling request. This approach dramatically reduces unnecessary requests. Now, why long polling is better? With regular polling, 1,000 clients polling every seconds may generate 1,000 requests every seconds, even when nothing changes. With long polling, most clients simply wait. Request only complete when new data becomes available. Far more efficient. Real world example is of Facebook. Early versions of Facebook chat used long polling. Many early messaging systems relied on it before WebSockets became popular. The problems with long polling are, although better than polling, it still has issue. Every update requires new HTTP requests, new HTTP response. Connections constantly open and close. At large scale, this becomes expensive. Engineers wanted something even better. And that's where the third solution emerged, that is server sent event, SSE. Engineers ask, what if the client opens one connection and keeps it open forever. And whenever the server has update, it simply pushes them down that connection, that server sent event. Let's walk through this architecture. The client opens a connection to the server. Unlike polling or long polling, the connection remains open. Now look at the arrows. The server can continuously send update through the same connection. Update 1, update 2, update 3. No new requests are needed. The server simply stream events whenever new information becomes available. The important limitation of SSE is, notice something important. The arrow only go one direction, from server to client, not both direction. This means SSE is excellent for live sports scores, stock prices, news feeds, monitoring dashboard, but not ideal for real-time chat because the client cannot continuously send messages back through the same connection. And that's where the next solution emerged, that is WebSockets. Engineer eventually wanted true real-time communication, not one way, two way. This idea leads to WebSockets. The WebSocket architecture look like this. The client open a WebSocket connection. Once established, both sides can communicate freely. Notice the double arrows. The client can send data to server. The server can send data to client. Both directions remains open simultaneously. This is called full duplex communication. Now why WebSocket feels instant? Imagine WhatsApp. You send a message, the server receives it immediately. The server pushes it to the recipient immediately. No polling, no waiting, no repeated requests. Everything happens over a single persistent connection. This is why WebSocket powered applications feel real time. Consider an example of WhatsApp. Let's follow the message. User A types a message. The message travels through an open WebSocket connection to the chat server. The chat server processes it, then immediately send it through another WebSocket connection to user B. No polling, no refresh, no delays. This is how modern chat system achieves real-time communication. Now let's try to compare all four approaches. Polling repeatedly asks the server for updates. Simple but inefficient. Long polling waits until new data exists before responding. More efficient but still creates many HTTP requests. Server send events, keep a connection open and allow the server to continuously push updates. Excellent for one-way streaming. WebSocket keeps a permanent two-way connection open. Perfect for real-time applications such as chat, gaming and collaboration tools. Now, let's try to understand some real-world examples of these techniques. Polling is used for simple dashboard, low-frequency update, legacy system. Long polling used historically for early chat system, early Facebook chat. Then server sent events used for stock market dashboard, news feeds, monitoring system, live sports scores. WebSocket used by WhatsApp, Slack, Discord, multiplayer games, Google Docs collaboration. Now let's try to understand some of the trade-offs of using these techniques. Polling advantages are it's very simple, easy to implement it. Disadvantages are it's wasteful, high latency, too many requests. Long polling advantages are it's better than polling, reduces unnecessary requests, and disadvantages are connection constantly recreated, higher server overload. SSE advantages are it's efficient, simple server push, automatic reconnection, and disadvantages are only one-way communication possible. WebSockets advantages are true real-time communication, two-way communication, low latency, highly efficient, and disadvantages are more complex, connection management required, harder scaling. Now let's try to understand some of the very frequently asked interview questions on this topic. What problem do WebSockets solve? Difference between SSE and WebSocket. Why is polling inefficient? When would you choose SSE over WebSockets? How does WhatsApp delivers messages instantly? Now let's try to understand some of the very common beginner mistake in this area. Thinking WebSockets are always better. This is the mistake 1. Mistake 2 is using polling for highly real-time systems. Polling doesn't scale well. Mistake 3 is using WebSocket when updates are only one way. SSE in this case may be simpler. Mistake 4 is ignoring connection management. Persistent connection requires additional infrastructure. Now let's recap what all are things we have learned. Polling repeatedly asks for updates. Long polling waits for updates before responding. Server sent events provide one-way real-time streaming. WebSockets provide two-way real-time communication. Polling asks repeatedly. Long polling waits. SSE streams one way and WebSockets communicate both ways. And that's how modern applications deliver real-time experiences to millions of users around the world.